In this chapter, we are going to talk about units and scientific notation, engineering notation. Chapter 1. First, we are going to start with some definitions. Scientific notation. What is scientific notation? A system of representing any number between 1 to 10. What does this mean? It can be any digit between a single digit to 2 digits to the power of 10. We are going to discuss accuracy. What is accuracy? What is precision? And significant digits. Significant digits we are not going to take too much into consideration until later, but accuracy indicates the range of error between the actual value and the acceptable value. The precision just means how many times you get the same result. Engineering notation. Engineering notation is a subsection of scientific notation, with the difference is that engineering notation we can have 1, 2, or 3 digits before the decimal point raised to a power of 10 that has to be a multiple of 3. Exponent. Basic definitions is what the number that the base 10 is raised to. Matrix system. It is a symbol that it is used to, instead of saying 10 to the power of 3, we use kilo. We are going to talk and give examples of this later. The power of 10 is always power of 10 because we have a decimal system. So it's 10 to the power of the exponent. Next, why scientific and engineering notation? Why is this important to talk about? It is important because we are going to be using very small and very large numbers, and we want to learn how to manipulate in specific ways that is not using so many zeros. So for example, here we have 47 million quantity. If we were to use scientific notation, we can have 1 digit to 2 digits before the decimal point. So in this case, we have 1, 4.7 to the base 10 to the exponent 7. Then the same number using engineering notation, where we can have 1, 2, or 3, but the base has to be raised to a power multiple of 3. So for it to be called engineering notation. So clearly here we see the two different, the same number is just expressed into different values. Another example, when we have a very, very small number, we make it into a very readable, easy to say number. Rather than say 0.000027, we say 2.7 to the power of negative 5. So when we are taking, this is important, when we are taking a small number and making it into a larger number, we want to make sure that the exponent it is negative. If we go back, when we are making a very large number into a smaller number, with the positive, the exponent is positive. Likewise, we have 2.7 to the power of 5, this scientific notation. If we want to use engineering notation, so we can use the prefixes that we are going to discuss later, it has to be a multiple of 6, so we have 27. Another example here, when we are asked to write something in scientific and engineering notation, keep in mind that a non-zero value has to be before the decimal point, okay? Here's a nice example. We see 6.05 to the power to the negative 1 scientific notation. Yes, it sounds better than 0.605, but if you write it in engineering notation and you write 605 to the power of 3, it just sounds better. Easy to remember, easy to manage. How to use the calculator. I'm not going to spend time here because you guys should know how to do this from your math classes. Here are the engineering notation prefixes, or the metric prefixes. But before we do that, we are going to start talking about units. What are units? So these are fundamental units. What does a fundamental unit is? Any kind of units that we are going to discuss later are going to be derived from these fundamental units. Fundamental units are not derived, but rather they are defined for us to derive more complicated units. So it's important that you remember the length for meters, the symbol M. For mass, we have kilogram. We have time for seconds. Current, this is defined. It's not a fundamental unit because we later will discuss that it actually comes from the electron, which is a fundamental unit, but it is easier to say amperes than coulombs. We have temperature for Kelvin, then luminosity in the substance of moles. These are for other classes, but yet they are under the fundamental unit definition. We will get very familiar with these electrical units. Most of them are derived. They are not fundamental except the current, the ampere, which is the only fundamental unit. So we have the coulomb, we have the voltage, we have the ohms, and we have the watts. They are represented with specific symbols. It is important to remember that all these ampere, coulomb, volts, ohms, and watts are name based after the person who discovered that quantity. Okay, so now we are going to go into the engineering metric prefixes. You might be asking yourself, why do I want to have engineering notation in powers of 3? Well, here is the reason why. Let's start for the kilo. Represented with lowercase, or uppercase actually, k, to the power of 3. So instead of saying 10 to the power of 3, you would say 10 kilo and then the units. The same case, if we are going up, if we are going large values, we are going to go 6, 9, 12, and 15. So we have mega, giga, tera, and peta as you go up. Likewise, if we go the other side of the stream, we are going to have a very small values. We have the milli. In a nice way, they organize it here for us as that if you're going smaller, then they go into the lowercase values. So you see milli, lowercase, then the Greek letter mu, and P and F, depending on the scale that we are talking about. Next, metric conversions. This is very important, okay? We are going to be seeing different ways that we can do metric conversions, and I will create a different video where I'm gonna say step by step how to make a metric conversion, okay? In this case, we're going from 0.47 mega ohms to, they want us to go to kilo ohms. If we go back to the previous slides, we know the kilo is smaller than mega. So what's happening to the value? The value is actually going to go from a small to a large, and we see that we go from 0.47 to 470 kilo ohms. I'll do a step-by-step example in the next video to show how that goes. And then likewise, we can go from a large value into a smaller value. So we are going from pico, which is smaller than micro, because pico is to the power of, if you guys don't remember, we have it here, it's power of 12, and then micro is power of -6. So pico is way smaller than micro. Again, I'll do an example step by step how to do that. Then we have metric arithmetic. How to add different exponents. It is very important that we remember this. When we add in two values, we want to make sure that they are in the same base. Here we have 10,000 times 10 to the power of what? Times 10 to the power of 0. plus 22 kilo ohms. We cannot add them. We have to set them in the same power base. So either we take this to the kilo or we take that to the regular representation. In the first example, we are taking the 22 kilo, we are replacing the K by its representation, which is 10 to the power of 3. And so then we can add them. Likewise, we could have taken the 10 to the power to the kilo, and then we could have added them. It is important to be careful when you are doing the exam or you're doing the homework to see how they are asked the answers to be represented. Okay, so it can be represented in regular, then you write 32,000. No scientific is just a regular number, or if they ask you to represent it in scientific notation, then it'll be 3.2, or if it is asked to be represented in engineering notation, it'll be 32 kilo ohms. More examples to keep in mind that if we are adding or subtracting, we have to follow specific rules. And I'll do a different video where I'm going to specify the specific rules to follow. Okay, and that concludes our video right here.